My lovely students, again, feel welcome. I just want us to go through this particular area of integral, but today I want us to look at both the indefinite integral and also the definite integral. Now, for the first one, where there's no limits, remember this one is open, where you are told to integrate this particular function. There are no limits provided. This particular integral, we refer to it as indefinite. That is indefinite integral. That is indefinite integral. Now, for this particular indefinite integral, then what are we doing here is that we are looking for a function that was differentiated to come up to this particular function. And to do this, remember, I'm going to therefore say that the integral of x squared 1 dx relative to x is going to be given by, what do we do here? Remember, here we are going to say that it is 2 plus 1 divided by 2 plus 1, then plus, remember x is not there, so we can say this one, 1x raised to 0 plus 1 over 0 plus 1, and then plus c. So what are we doing here? When we are integrating, what you are doing is that we are adding 1 to the power, and then we are dividing with the resultant that we are getting from that particular one. And therefore, this one you're going to have that the function y is equals to x cubed over 3, then plus x plus c. So anytime we are integrating a particular function, especially the indefinite integrals, what we are doing is that we are adding 1 to the power and dividing by the resultant. But the point I want you to note here that the integral of a constant, let's say 2, respect to this one, is usually 2x plus c. There's an x that we add there. Similarly, if you have 1 dx, still you're going to get x plus c. That is what you should notice. That's why the integral of 1 has come to x, and I've provided that one. Remember, we have said anytime we have a number or a constant with no variable, we have to introduce a variable, but we raise it to 0. Remember, any number raised to 0 is just 1, and therefore we add 1 to that particular variable, and then we divide by the resultant. And you see, what is coming up is now the integrated function. Now this one, remember also that for indefinite integral, we usually end up with a constant c. That is a constant of integration. This constant can be determined if we have initial condition for that particular function. Now, the second one, we refer to it as definite integral. For this definite integral, what happens? Limits are provided. And when the limits are provided, then what you expect is a numerical value. Remember, for indefinite integral, we are integrating to get a new function. But for definite integral, because you have limits, the final answer should be a numerical value. This is how we proceed it as solution. Then we are going to have that x raised to 5 divided by 5. Remember, we said we add 1 and then we divide it, minus 5 raised to x. That is what you're going, but you're not going to introduce a c, but we say from now 0 to 1. I'm not introducing c because in the process of calculation, that c is going to cancel out. Once we do that, remember, after integration, these limits move to the other side as a slash with the limits on the other side. Once you're at that particular point, you substitute with the upper number first, which will be 1 raised to 5 over 5 minus 5 into 1. You close it into bracket minus, then you substitute the lower number, 0 raised to 5 over 5 minus 5 into 0. Then you close the bracket. Once you're at that particular point, you actually work out, which will be 1 over 5 minus 5, then minus 0. Now this one is going to be negative 4 over 5 minus 0, which ends up to being negative 4 over 5 as your final answer. And that's why we agreed that when you are using this particular approach, remember that when you have an definite integral, the solution you're expecting at this particular is a numerical number. Remember to follow me for more interesting and educative videos on mathematics and also in physics. Thank you and be blessed.